Okay, so topic 5, the difference between fission and fusion. There is a typo here. It is fission, F-I-S-S. Okay. So the word meaning, fission means splitting and fusion means combining. Okay. So in nuclear fission, a large heavy nucleus splits into smaller nucleus and release lots of energy and few neutrons. Okay, we'll talk about this in a minute. So look at this image. So we are starting with uranium 90 to 235. We will collide this with the neutrons. So this will absorb a neutron and convert into uranium 236, which is very unstable nucleus. So to start the nuclear fission, we need neutrons, and that will then split into two lighter nucleus. You can see barium 56 and krypton 36. They are both become stable, and the 56 plus 36 is 92, but mass number there is a difference. That means there will be extra 3 neutrons and a huge amount of energy will be released. These 3 neutrons will activate 3 another uranium, again will produce 9 neutrons. That will activate 9 will produce 27. That's why we are saying that will be a chain reaction, will continuously happen, will destroy the place where this heat will exist, that radiation, for a long time. Okay, then fusion means two lighter smaller nucleus combines to form larger nucleus, releases energy. Okay, it needs extremely high temperature and pressure. That is very important. Say for example, it is usually happening only in sun or stars or anything in space, because it needs higher temperature and higher pressure. Wherever it has, that will takes place. Say for example, hydrogen, this 1H1, that is called protium, one of the isotope of hydrogen, combines with 1H3, which is tritium. It is present in only in space or sun's atmosphere. At very high temperature and pressure, they will combine and form what? Helium nucleus. Or we can, instead of protium, we can say take deuterium, and there will be 2, and again there will be a subatomic particles like neutrons will be produced. Okay, so that's what given here. Okay, so we are going to compare and contrast between fission and fusion. I already wrote this. I'm not going to erase and write it again. Okay, so first one I will go a highlight. Splitting heavier nucleus. This one is combining smaller nucleus. Okay, go ahead and write that. It starts with heavy elements, starts with lighter element. Needs a neutron to start. We said it needs to bombard with a neutron. It needs very high temperature and pressure. And since neutrons are producing, it will continue. That is a chain reaction. This is not a chain reaction. And it produces a lot of nuclear waste. This will produce only little waste. Used in nuclear power plant and atom bombs, we can use for goods and bads. This is naturally occurring in, and this is the source of our energy from sun. Okay, now both produces energy and both produces radiation, right? There will be change in identity. Protons and neutrons are changing. Mass is converted into energy. We already know this equation, you don't need to write it. And there will be production of new elements. Okay, now practice. Let's go erase that. Okay, so let's see this example. We are going to identify whether it is. So there is 2 lighter and you see 1 neutron. So there is no other particle, so I'm going to combine this. That is 5 minus 1 will be 4, that is helium. So 2 lighter become heavier, so that is fusion. Now you see a bigger one, starting neutron. There is another lighter one. Okay, so we have to find the second one, so it will be cesium 55 139. So there will be neutrons. To balance, you have to add 2 neutrons and lots of energy. Since you can see it is a heavier combined, heavier split into lighter, that will be what? Fission. Okay, complete this. So whenever you see starting neutron, you can go say that is what? That is fission. Then double check for sometimes. Okay, for double check. Those are all fissions and the rest is fusion.